Hello. In the last class, we have discussed it till the standard form, right? How to bring any equation in the form of ax square plus bx plus c equal to 0. This is standard form. Standard form of quadratic equation. So we have already seen how we have already seen any equation can be converted into the standard form, and from that standard form we can find the coefficient values of a and b and c. And I have told you how to find the roots of the equation, right? Roots or solution. I am going to teach now how to find the roots or solutions for the quadratic equations. So we have already discussed like we have already discussed that there are three methods to find the roots of a quadratic equation. The first method is formula based method, and the second method is square method, and the third method is factorization method. So there are three methods to find the solutions of quadratic equation. So in one by one we will see what are those methods. So first we will see this formula based method. We will see first. So what is formula based method? We know any equation can be converted into standard form. What is the standard form? Like ax square plus bx plus c equal to 0 is the standard form. And by comparing any other equation to this standard form, we can get the coefficient values of a and b and c. So after getting these constant values, we have to substitute these values in the formula, and then we will get the direct values of roots or the solution. So this is a standard equation. We will take this as a reference, and for this we will write the formulas how to find the roots. See, we already discussed this is a quadratic equation of degree 2. So how many solutions exist for this type of quadratic equations? As it is of degree 2, there are two solutions, or we call as two roots of the equation. Two roots of equation. So what is meant by the roots of the equation? Suppose x1 comma y1, x1 comma x2 are the roots of the equation. So that means that in some value like 4 or 5, so x1 equal to 4 or x2 equal to 5 are the roots of a quadratic equation. When we will tell that if we substitute this point in this equation, it satisfies that equation. That means a x1 square plus b x1 plus c equal to 0. So it should satisfy this equation. Also, as x2 is also one of the root of the equation, a x2 square plus b x2 plus c equal to 0. So this must also be correct. If any point x1 if it is a root of this equation, then it must satisfy this condition also. Like when you substitute that value in this quadratic equation, it must satisfy. So we will solve the problems based on this. So how to find these roots x1 and x2? So we have a formula. So what is that formula? So what is the formula? X is equals to minus b plus or minus under root of b square minus 4ac divided by 2a. This is the general formula. This is the general formula to find roots of quadratic equation. So what is this plus or minus? So x1 can be written as, so I'll put this is in box. So one of the root can be minus b plus under root of b square minus 4ac divided by 2a, and one more root for x2 can be minus b minus under root of b square minus 4ac by 2a. So one root can be plus and other root is minus. So this is the general formula. So we know that the standard equation is in the form of ax square plus bx plus c equal to 0, and by comparing any other given equation with this standard form, we will get a value, b value, c value, coefficients. So if we get a, b, c coefficient values, we will substitute these values in this formula to find two roots, x1 and x2. See, one more thing. Every quadratic equation, this is of degree 2. The quadratic equation is of degree 2. So it has two roots. See, two roots does not mean that x1 can also be equal to x2. That also implies 0. Suppose if x1 is equals to 0, so and x2 is equals to 0, it means two roots only. But these x1 and x2 values are equal. Means two roots does not mean both the roots are different. I mean, I'm not telling if two roots are there, x1 can equal to x2 also, it is also two roots. If x1 not equal to x2 also, there are two roots. If x1 is not equal to x2, obviously we know that this is different and this is different. What I'm telling is these two can also be equal. I'm telling these two can also be equal. So we will have equal roots. Equal roots. We can have equal roots. We can have different roots. That is the thing. So that is about the formula. So we will see what's the formula. See, there are three ways to find solution, as we have already discussed. One is factor method, one is square method, one is formula method. So this is a formula given. What is that? For this formula we have taken, what is the standard equation? Ax square plus bx plus c equal to 0 is the standard reference equation we have taken to derive this formula. So x equal to minus b plus or minus under root of b square minus 4ac divided by 2a. So that is the formula of roots. So one root can be, I mean, if x1 is one root, it will be minus b plus under root of b square minus 4ac by 2a, and one more root x2 can be minus b minus under root of b square minus 4ac by 2a. So these are the two roots of the quadratic equation of this standard form. We will get those a, b, c values by comparing with the given equation, and then we will substitute those values in x1 and x2. So we will see the example problems clearly. So here it is taken alpha, beta are the two roots here taken. So any roots we can take. Like this can be, this alpha is taken as x1 and beta is nothing but x2. So any roots it can be taken. See, thus ax square plus bx plus c equal to 0 has two roots, alpha and beta. Alpha can be given as one time will take plus and one time will take minus. So minus b plus or minus b square minus 4ac by 2a. See, you also revise 2-3 times by telling this formula. You will get to remember permanently. Like my x equal to minus b plus or minus b square minus 4ac by 2a. So like that, if you go on reading with your mouth loudly, you can able to remember this formula. So let us solve the equation. So this already we have taken. This is a quadratic formula, minus b plus or minus b square minus 4ac by 2a. So this is a formula. Okay. So now you tell me if alpha, beta are the roots of the equation. So what are alpha? Alpha is equals to, alpha can be written as minus b plus or minus under root of b square minus 4ac by 2a. So one will take here plus, and beta can be taken as minus b minus under root of b square minus 4ac by 2a. So like this you have to practice. Okay. So next, so in this part we have in root we have some part. This is under root of b square minus 4ac. So that is called as discriminant. What is discriminant? We write the formula here. X is equals to minus b plus or minus under root of b square minus 4ac by 2a. What this under root part, that is which is present in this root. So that can be written as, I'll change that. So b square minus 4ac is called as determinant or discriminant. Discriminant. Is it correct? Discriminant. So if this is main discriminant, or we call it as d. D is equals to b square minus 4ac. You tell me, this is under root, the discriminant or root d, we call it as root d, because this d is is under the root. So what are the special features if values of d is negative, 0 and positive? If, see, first of all, this is called discriminant, that should be remembered. That is in minus b plus or minus under root of b square minus 4ac by 2a is a formula for the roots. What is the part that is under the root? That is b square minus 4ac. The part under the root is called as discriminant. So if d is greater than 0, what will happen? If d equal to 0, what will happen? If d less than 0, what will happen? You only tell me. If d greater than 0, what will happen? So first of all, it is easy. If d equal to 0, what will happen? Substitute here d equal to 0. What is d equal to 0? B square minus 4ac equal to 0. D equal to 0 means, so substitute in this equation. X is equals to minus b plus or minus under root of, this under root of b square minus b square minus 4ac is nothing but discriminant d. If discriminant d equal to 0, under root value will be 0 divided by 2a is equals to minus b plus or minus under root of 0 is 0 only. So plus or minus b 0 by 2a. Plus or minus 0 has no value. This has no value. So what will be the answer? Minus b by 2a. Okay. So x is equals to minus b by 2a. So it means both x1 is equals to x2 is equals to minus b by 2a. That is equal roots. The quadratic equation has equal roots. Okay, the quadratic equation has equal roots. If d equal to 0, equal roots. So one more thing. What if d less than 0 and d equal to 0? Let's see. So the expression b square minus 4ac. So the expression the expression b square minus 4ac in the formula. This is a formula for the roots. If this is the formula, this is called discriminant, because it can discriminate between the possible answer types. It can be denoted by d, as I already mentioned. So d is equals to b square minus 4ac, where d is called as discriminant. See, you also parallelly write the notes, take the notes. So this is called as discriminant. When if d is positive, we will get, if d greater than 0, we will get two solutions. That is, and that are what kind of solutions? Two real solutions we will get. Real solutions. See, as I am discussing here, don't worry that I am not understanding what does two real solutions means. While solving the problems, we can easily able to understand what is the meaning of d greater than 0, what is the meaning of d less than 0, what is real solutions, what are imaginary solutions. So like that we can able to solve. And d equal to 0 has equal roots. That is only one solution it has. Only one solution. Equal roots. And d less than 0, what will have? We have two complex roots. Two complex solutions. So those are the things. So when d greater than 0, we have two solutions, that is two real solutions. When d equal to 0, we have only one real solution. Only one real solution. Or we call as equal roots, because both alpha and beta are same here. And when d less than 0, we have two complex roots. Like, see, here if d greater than 0, we have roots are real and unequal. If d equal to 0, we have equal roots and real roots. Each value is minus b by 2a. This already we have seen. If d less than 0, we have no real roots. We have complex roots. We have complex roots. Okay, I'll explain one more time. See, we have standard form ax square plus bx plus c equal to 0, standard form. From this, what are the roots of the equation? We will write it is minus b plus or minus under root of b square minus 4ac, we will write, divided by 2a. If, and what is discriminant d? D is called as discriminant. Discriminant is equals to b square minus 4ac. If d value greater than 0, we will have one solution. We will have one condition. If d equal to 0, what will happen? If d less than 0, what will happen? So let's see what will happen. If d greater than 0, we have two solutions. And how are the solutions? Real. If d equal to 0, then also we have only one solution we will have. What are them? Real solutions only. If d less than 0, we have two solutions. But how are they? Complex. First of all, I have to tell you what is the difference between real numbers and complex numbers. In our already lectures, we have already discussed what are the differences between real numbers and complex numbers. So what are real numbers? Suppose I am telling 1, 2, 3, 0. So these are all real numbers. Or 1.1, 1.2. Even these are also real numbers. Or 2 by 3, under root 3. So these are also real numbers. But what are complex numbers? Under root of minus 3. Can you find out what under root of minus numbers? No, you can't find. So these are called as, it's like we denote these complex numbers with the letter I. I value is under root of minus 1. So we will represent these complex numbers with I. But in detail of complex numbers we will discuss later. So root minus 3 can be written as root minus 1 into 3 we can write is equals to minus root 1 into root 3 we can write. This can be written as I. So it will become root 3i. This minus of root 3 will become root 3i. So this is complex numbers. We will see in the complex and real numbers chapter in detail. So in general MCQ type of problems, the questions are asked like this. What if the discriminant value is greater than 0? We will have two solutions that are real. That is like this 1, 2, 3, 0 or 1.2, 1.3 or 2 by 3 or root 3. These like this solutions we will have. If d greater than 0, we have two solutions. Two different solutions. Okay. And what if d equal to 0? We have only one solution. That is equal solutions. Both are equal solutions. What if greater than d less than 0? So we will have two solutions, but those are complex, not real solutions. So this is all about the types of the solutions we will get. So this is our first example. We will solve our first example. So let us take what is the equation? What is the equation given? 5x square plus 6x plus 1 equal to 0. Yes. So we write here detailedly. So what is the question given? 5x square plus 6x plus 1 equal to 0. So this is the equation given. What is the first step you have to do? First step 1. Step 1 is, what is our standard form of our equation? Ax square plus bx plus c equal to 0. So compare the given equation. So this is a given equation. That is the problem, given equation. So compare the given equation with standard form. So by comparing, what we will get? This is ax square plus bx plus c equal to 0. And the given equation is 5x square plus 6x plus 1 equal to 0. By comparing, what we will get? What is the coefficient of x square here and x square here? So by comparing, we will get a equal to 5. And what is the coefficient of x and x here? By comparing, we will get b equal to 6. What is the constant value here? C. I mean the c into x power 0 we will write. So what is the coefficient of x power 0 here? C. And what is the here also we will write 1 into x power 0. So c equal to 1. So these are the values we get. A equal to 5, b equal to 6 and c equal to 1. So this is the values we got. So this is just step 1 only. So what is the step 2 we have to do to find the solution? Step 2. We have to substitute these values in the formula. So what is our formula? We have formula x is equals to minus b plus or minus under root of b square minus 4ac divided by 2a. So this is our formula. So in this we have to substitute our in this value we have to substitute our a, b, c terms. First of all, let us see. First of all, we know discriminant. Discriminant. What is the formula of discriminant? Discriminant. Discriminant d is equals to b square minus 4ac. So that we will know what are the nature of the roots. So let us find the what. Substitute these values in the b square minus 4ac. What it will become is equals to b. What is b? 6 whole square minus 4 into what is a? 5 into what is c? 1. So what is 6 square? 6 into 6. 6 into 6 minus 4 into 5 into 1. What is 6 into 6? 36 minus 5 for the 20. 20 into 1, 20. So minus 20. What is 36 minus 20? It is 16. So discriminant is equals to 16. Whether it is a greater than 0 or less than 0, it is greater than 0, right? So discriminant value is greater than 0. So what we got? Discriminant is equal to 16, which is greater than 0. So what are the nature of roots? So we will get two roots which are real. Two real roots we will get. So we'll substitute that a is equals to how much we got? A is equals to 5, 6. I mean a 5, b 6 and c 1. We'll substitute it. A is equals to 5, b is equals to 6 and c is equals to 1. So we have formula x equal to minus b plus or minus under root of b square or minus 4ac by 2a. We already found the discriminant value d is equals to how much? 16 we found, which is b square minus 4ac. So let's substitute these values in this equation and this also in this equation. So roots is equals to x1. Let us find x1. x1 is equals to minus b plus under root of b square minus 4ac divided by 2a. So x1 will become, what is minus b? Minus 6 plus under root of b square minus 4ac value is 16. That is discriminant we have already found 16 divided by what is 2a? 2 into what is a value? 5. So a equal to 5. So x1 is equals to minus 6. What is root 16 value? Is it 4? Yes, it is 4 plus 4 divided by 5 to the 10. Yes, it is 10. So what it will be is equals to minus 6 plus 4. It will be minus 2 divided by 10. It will be how much? Minus 0.2. This is one of the root. What will be the other root? x2 is equals to, here one time we have taken plus. So next time we have to take minus. So it will be minus b minus under root d we will write directly divided by 2a, because the d is nothing but b square minus 4ac, which is 16. Let us substitute x2 is equals to minus b is minus 6 minus root d is minus 16 divided by 2 into what is a value is 5. So it will become minus 6 minus root 16 value is 4 divided by 5 to the 10. So x2 will become minus 6 minus 4 minus 10 by 10. It will become, what is minus 10 by 10? Minus 6 minus 4, it will be minus 10. Minus 10 by 10 is minus 1. So what we got? Two roots. x1 is equals to minus 0.2 is one root, and x2 is equals to minus 1 is another root. So keep this in mind. x1 we got minus 0.2 and x2 we got minus 1. Okay. So we got x 1 is equals to minus 0.2, x2 is equals to minus 1. See, I have already told you, if these are the roots of the quadratic equation, we have already told these are the roots of equation. So what I told, these, if we substitute these values in this 5x square plus 6x plus 1 equal to 0, then we should get the same answer. I mean, it should satisfy this equation. We should get 0. So let us substitute x1, I mean 5x1 square plus 6x1 plus 1 equal to 0, it should satisfy. Let us substitute x1 value. So 5 into x1 is minus 0.2 whole square plus 6 minus 0.2 plus 1 is equals to 0. Let us take new screen. So what it will become? 5 x1 square plus 6 x1 plus 1 is equals to 0. So x1 is equals to minus 0.2. Let's substitute in this minus 0.2. What will get? 5 into minus 0.2 the whole square plus 6 into minus 0.2 plus 1 is equals to 0. It will become 5 into, so it will become 2 by 10 into 2 by 10, because 0.2 can be written as 2 by 10, and minus whole square will be positive only again. 0.2 into 0.2 plus, so 6 into minus 0.2 plus 1 is equals to 0. So what it will become? 5 ones are 5 twos are 2 ones are 2 twos are, so it will become 2 by 10 plus, so it will become minus, because 6 into 0.2 it will become minus 1.2 plus 1 is equals to 0. 0.2 can be written as 2 by 10 can be written as 0.2 minus 1.2 plus 1 is equals to 0. So this 1 and 0.2 will become 1.2 minus 1.2 is equals to 0. So 0 equal to 0. Hence it's satisfied. Hence we have proved that x1 is equals to minus 0.2 is a root of the quadratic equation. X square 5x square plus 6x equal to 1. So similarly we will solve for another root we got. What is another root we got? x2 is equals to minus 1 we got. Let us prove whether that is also satisfying the quadratic equation or not. So we write 5x2 square plus 6x2 plus 1 is equals to 0. So what will we get if we substitute this value here? 5 into minus 1 whole square plus 6 into minus 1 plus 1 is equals to 0. We will get 5 into 1 square minus 1 whole square, also 1 square also 1. So 5 into 1 minus 6 into minus 1, it will become minus 6 plus 1 is equals to 0. So 5 into 1 is 5 minus 6 plus 1 is equals to 0. So what is 5 plus 1? 6. 6 minus 6 is equals to 0. So 0 is equals to 0. Hence correct. This is correct. Hence x2 is equals to minus 1 is also a root satisfying the quadratic equation. So x1 comma x2 satisfies the quadratic equation. Hence therefore x1 is equals to minus 0.2, x2 is equals to minus 1 are the roots of the equation. What is the equation? 5x square plus 6x plus 1 is equals to 0. These are the roots of that equation. So like this is the procedure to find the roots of any equation. Okay. So let us see one more problem, example problem. So these are the proofs that substituting x equal to substituting the values of 0.2 and x equal to minus 1 in this equation and these equations. We already proved these equations, right? So that's the thing.